It's time to talk more about erections, because let's face it, they're pretty important for multiple reasons, especially from the standpoint of reproduction. Now, much of the discussion about erections will often focus on the male erection, and that may be because the male erection is a little bit more noticeable than, say, like the female erection. But make no mistake, females very much come equipped with functional erectile tissue. But how important is the female erection from the standpoint of reproduction? Because as we've already alluded to, a male erection and the release of sperm cells is pretty important when it comes to successfully completing reproductive intercourse. So does that female erection and climax also play a key role in successful reproductive intercourse? Or is it more of an added bonus to the female for other reasons? Well, we're about to find out, as well as just talk about how it works. So let's jump right into this reproductive anatomical awesomeness. Interesting is that male and female erectile tissue structures are surprisingly very similar. So throughout this video, we're going to reference these things called homologous structures. And for our discussion, these would be things that develop from the same embryonic tissue. So for example, the testes and the ovaries develop from the same embryonic tissue and are therefore homologous structures. And more importantly for this erection discussion, the penis and the clitoris are homologous structures and have the same erectile tissue. So let's start by taking a look at the clitoris and therefore the erectile tissue so that we can figure out everything that's going on here. So the clitoris is essentially the cylindrical mass of erectile tissue. And as you can see, it's made up of various parts. It arises from two leg-like extensions, and the word for leg in anatomy is crus, or the plural version is crura. So these are called the crura of the clitoris. And the crura are located on the actual ischial and pubic bones on both sides. And as we take a look at this on the cadaver dissection, let me first orient you. This is an inferior view, or looking from the underside. And keep in mind, to get to this view, we also had to remove the external genital structures. So we had to remove things like the labia majora, labia minora. And you can also see some pretty large muscles here. These are often referred to as the groin or the adductor muscles, just again for another frame of reference. But finally, we can take a look at the right crus of the clitoris right underneath my probe here. The left crust we can't see because it's covered up by some of these tiny and even amazing skeletal muscles that we removed on the other side. But these skeletal muscles we'll talk about in just a little while because they get involved in helping to maintain the erection. Now, the crus, or the crura of the clitoris, will actually bend off of the pubic bone and come together and unite to form the body of the clitoris. Now, the body of the clitoris is homologous with the body or the shaft of the penis, and you probably already guessed that the crus of the clitoris would be homologous with the crus of the penis. But when we take a look at it on the cadaver dissection, you can again see here would be the body of the clitoris. And again, this would also be covered up by external genital structures. The only visible portion of the clitoris is the very end or tip of it, which is called the glans clitoris. Shocker, homologous with the glans penis. But the glans clitoris is located at the anterior junction, or where the front of the two labia minora kind of unite or come together. And the labia minora are these bilateral folds of skin, the inner bilateral folds of skin, that pretty much surround the entrance into the vaginal canal. And if we go back to the cadaver dissection here, again, there's the body, and then going down to the end of the tip, this would be the glans clitoris here. Now, the glans is packed with sensory nerve endings, so very important for sensation, as well as initiating and maintaining the erection. So how does the initiation and the maintenance of the erection actually work? Well, we're going to approach this from two different scenarios. Now, these scenarios can happen independent of each other, but they can also happen in conjunction or at the same time. So the first scenario we'll mention is simply just tactile stimulation or touch of the glans and other surrounding genital structures. That'll send a sensation or a signal into the spinal cord through a nerve called the pudendal nerve. Now, if you've watched our previous erection video, you know that pudendal translates to that which you should be ashamed of, because apparently the anatomists hundreds of years ago were ashamed of their genitals for some reason. But once that signal gets relayed into the sacral portion of the spinal cord, it will specifically go into the sacral levels S2, 3, and 4. And when I was teaching this in college, we had a saying, S2, 3, and 4 keeps the penis off the floor. But it also certainly works as this. S2, 3, and 4 also keeps the clitoris off the floor, so it works for both. But part of that signal, yes, will go up the spinal cord to the brain so that you are aware of such tactile stimulation or what's going on down below, but it doesn't technically have to. This scenario that we're talking about with tactile stimulation actually works primarily reflexively, meaning that the signal will go into the spinal cord, but most of that signal will just get kicked right back out of the spinal cord and go directly to the internal erectile tissue of the clitoris. I kind of think of it this way, is like, we're going to give the brain a common courtesy of being like, hey, there's this signal coming in, we're going to let you know something's going on down here, but we don't really need your permission to do this. We're going to just send that signal right back out to the clitoris and initiate the erection. So somebody with a spinal cord injury could technically still get an erection initiated from this tactile stimulation. But that doesn't mean the brain doesn't get involved in initiating and maintaining the erection. It's just with that particular scenario, it doesn't technically need it. Now, we know that the best erections tend to happen with the brain and tactile stimulation working together in conjunction, meaning that the brain starts to send signals down from, say, like, you see someone that looks very nice to you. You have certain thoughts and imaginations. Even certain smells can be arousing. Maybe somebody whispers something in your ear that excites you in a very specific way. And that signal can come down. It can initiate an erection if somebody wasn't being tactilely stimulated, or if it's occurring at the same time, these signals will converge in that S2, 3, and 4 region of the spinal cord and send these signals out through certain nerve fibers to go to the internal structures of the clitoris, and these nerve fibers will release their neurotransmitters, which will then cause nitric oxide to be released within the erectile tissue. And this is where the magic happens. So if we were to take a cross section or a cut right through the body of the clitoris, we would see that there's these two distinct masses of erectile tissue, or erectile tissue bodies, called the corpora cavernosa. Now remember, the crura came off the pubic bone and came together to form the body of the clitoris, and that's what these things arose from, those crura, and now we have the corpora cavernosa. And this is a vascular cavernous erectile tissue. Vascular because there's lots of blood that can go in there, and cavernous because there's these hollow spaces or sinuses that are going to fill with blood. So nitric oxide has this powerful effect as being a powerful vasodilator. So meaning the blood vessels within will open up and allow for more blood to come into this erectile tissue, and also affects this cavernous erectile tissue by relaxing the smooth muscle within, so those spaces will enlarge to allow for even more blood to fill. Now, this will enlarge the clitoris. Obviously not to the same degree as, say, like an erection with the penis, but the clitoris will enlarge compared to its non-erect state nonetheless. So back to the question we had at the beginning of how important is a female erection and climax to the successful completion of reproductive intercourse, or just even reproduction in general, because there are artificial means to also do this. Now, granted, the majority of these episodes of consensual coitus or intercourse are not just about creating a baby or reproduction. There are various reasons why people participate in intercourse. It feels good, stress reliever, bonding and connections formed between people, various other reasons that we could come up with. But from the standpoint of purely getting sperm cells from the male reproductive tract and into the female reproductive tract to fertilize an egg, how important is that female erection and climax? Well, you probably could have answered at the beginning of the video that it's technically not necessary. As long as the sperm cells get into the female reproductive tract, it could technically still fertilize an egg. Now, beyond that being just bad business practices to not have the erectile tissue fully engaged with all parties involved, that doesn't mean that the female erection and climax can't help with this process of fertilization. Now, one other structure that we haven't mentioned yet is another erectile tissue mass that's found on both sides of the vaginal canal, called the bulb of the vestibule. Now, if we take a look at that on the cadaver dissection, again, we can just reference that crust of the clitoris that we saw earlier, but right underneath my probe here is the bulb of the vestibule. Now, we can't see it as well on the left side because it's covered up with a muscle called the bulbospongiosus muscle, which is a pretty good name for a muscle that's covering the bulb of the vestibule. But that muscle, when it contracts, will just help facilitate the function of this bulb of the vestibule, which is when it engorges with blood or becomes erect, it will narrow the vaginal canal around the penis and thereby increasing the stimulus and facilitate the climax and the release of the sperm cells. Now, you could make the argument that's just helping the male reproductive tract. But if we keep digging a little bit deeper, we're going to see some really cool things that happen with the female reproductive tract. Now, one of the things that I need to mention is that it is known that a female inseminated naturally through intercourse tends to be more fertile or have an increased odds of getting pregnant as compared to if the same female were inseminated artificially. Granted, artificial insemination works, it's just all things being equal, the natural intercourse tends to increase the odds. So there's the question of, well, why is that? And it's thought to center around female climax, or in other words, what happens during female orgasm. During female climax, some awesome things will occur. One of those is that the pelvic floor muscles will start to rhythmically contract, and this will help propel the sperm cells further upstream towards the uterus. The uterine canal will also dilate or open up, which will help facilitate the flow of these sperm cells. Oxytocin is also released from the pituitary gland. Oxytocin is a hormone with various functions, one of which is to cause the uterus to contract. And if there are any sperm cells in the uterus, that contraction will help propel the sperm cells even further, getting closer to fertilizing that egg. So you can see just from a reproductive standpoint that the climax within the female can help increase the odds of that. Now, we could talk about the odds of successful fertilization from a different perspective, or a different numbers game, if you will. Let's say a female had multiple previous encounters of enjoyable intercourse that included climax. Said female would probably be more likely to continually engage or more frequently engage in intercourse. And we could make the argument that this would also increase the odds of successful reproductive intercourse.